The geocentric model of the universe remained the main one for almost 1.5 millennia. Claudius Ptolemy created an incredibly complex mechanism made of deferents and superimposed circular epicycles. This artificial construct successfully explained the strange retrograde motions of planets observed from a stationary Earth. However, by the 16th century, Ptolemy's mathematical model had completely run into a dead end of impracticality.
For over 1,500 years, the way we saw the universe was shaped by one person, Claudius Ptolemy. Now, his model, with the Earth at the center, it wasn't just some wild guess. It was this incredibly sophisticated mathematical machine built to predict the movement of the heavens. And you know what? It was completely, profoundly wrong. But its genius is just undeniable. So today, let's explore the anatomy of this flawed, yet truly brilliant universe. So you have to ask yourself, how does a map of the universe that's just fundamentally incorrect manage to dominate science for 1.5 millennia? The answer isn't just about belief. It's about the incredibly clever predictive mechanics of this grand Earth-centered machine. And that's exactly what we're going to take apart piece by piece. All right, here's our game plan. We'll start with the foundational ideas, the bedrock of the whole system. Then we'll build its mechanical structure and see how it solved that huge puzzle of retrograde motion. After that, we'll uncover a fascinating little secret, the hidden but vital role of the sun. And finally, we'll ask why this thing stuck around for a staggering 1,500 years. You know, every scientific model has to start with some basic assumptions, some postulates you take as true. Ptolemy's system was built on a foundation that, at the time, seemed perfectly logical. It was a mix of what you could see with your own eyes and the big philosophical ideas of the day. So in his masterpiece, the Almagest, he lays out these key postulates. First, the Earth is a sphere. Hey, he got that one right. Second, this sphere is sitting right at the center of everything and it's not moving. And third, and this is a big one for Greek thought, all motion in the heavens has to be perfect, which to them meant uniform, unchanging circles. So here's the problem. You look up, and the planets seem to wander all over the place. But your philosophy demands perfect circles. What do you do? Well, Ptolemy came up with this incredibly clever mechanical system, almost like a set of celestial gears. And it all relied on two main parts, the deferent and the epicycle. Okay, first up is the deferent. Just imagine a huge main track, a perfect circle with our stationary Earth right in the middle. For something simple like the sun or the moon, you could almost stop there. But for the planets, this was just the beginning. This was only the foundational orbit. Now, attached to that main track is the second, truly brilliant piece, the epicycle. This is a smaller circle, and its center rides along the deferent. Meanwhile, the planet itself is spinning around on the edge of this smaller circle. It's a compound motion, literally like a wheel on a wheel. Why go to all this trouble? Well, this whole complicated setup was designed to solve the single greatest astronomical puzzle of the ancient world, retrograde motion. Those wandering stars, the planets, would sometimes slow down, stop, and actually appear to move backward in the sky. This deferent epicycle system was built specifically to explain that weird little dance. So when you put it all in motion, what you get is this beautiful, complex, looping path. You've got the epicycle center gliding along the main deferent track, while the planet itself is orbiting on that epicycle. And the combination of those two simple, perfect circles creates this really complex trajectory that could finally explain what we were seeing in the night sky. How it makes things go backward is just a clever bit of adding and subtracting speeds. See, when the planet is on the outer part of its epicycle, its speed adds to the speed of the deferent, so it looks like it's moving forward and fast. But when it swings around to the inner part, its motion is going in the opposite direction of the deferent. If that epicycle is spinning fast enough, the net result from our perspective on Earth is that the planet appears to be moving backward for a little while. But it turns out just deferents and epicycles weren't quite enough to get the predictions right. Ptolemy had to add in some very specific, kind of clunky rules to make the model match what people were actually seeing. And the funny thing is, all these little mathematical fixes pointed to the hidden influence of one object, the sun. He had to create two totally different rules. For the inner planets, Mercury and Venus, he had to decree that the center of their epicycles must always stay on the line between the Earth and the sun. For the outer planets, like Mars and Jupiter, the rule was different. The line from the epicycle's center to the planet had to stay parallel to that same Earth-Sun line. Now, these weren't elegant principles, they were just fixes he had to bolt on to make the math work. So what's really going on here? It means that inside this supposedly Earth-first, Earth-centered universe, the math only worked if you secretly tied everything to the sun. The model was geocentric in its philosophy, but to actually make predictions, it was forced to become heliocentric in its calculations. And that was a deep, deep crack in the whole foundation. And that brings us to its legacy. How on earth did a system built on a wrong idea, with all these weird, artificial rules, manage to dominate science for longer than any other theory in history? 1,500 years. I mean, let that sink in. For nearly 1.5 millennia, this wasn't just a theory about the cosmos, it was the theory. Its authority was nearly absolute. It didn't just shape astronomy, it shaped philosophy, religion, everything about how we saw our place in the universe. Its incredible success really stood on two pillars. First, it just felt right. It matched our everyday experience of standing on a solid, unmoving Earth. And second, and this is the really important part, it worked. For anyone just looking at the sky, its predictions of where the planets would be were amazingly accurate. Its downfall started when our observations got better. To fix the new little errors, astronomers just kept adding more epicycles on top of the old epicycles, creating this monstrously complex Rube Goldberg machine. By the 1500s, it just became too clunky and unreliable for really important stuff, like navigating ships across the ocean. So this leaves us with a final, fascinating question. Is it fair to call the Ptolemaic system a failure? I mean, it worked for 15 centuries, but its basic idea was completely wrong. Maybe its real legacy is showing us that a scientific theory can be incredibly useful, mathematically powerful, and still be a total misrepresentation of reality. It really makes you stop and ask, what does success even mean when we're trying to understand the universe?
Thank you, friends. Strive for understanding and become wiser. See you soon.